So for the panel discussion, I thought we'd, roughly speaking, break it into two parts. The first part will be similar to this morning's discussion. So if you have any general points related roughly to this afternoon's talks, please ask questions and discuss to your heart's content. And then perhaps we'll allow the discussion to get even broader and talk more generally about the role of the climate scientist. And I just put up a few ideas there just to make you think about what might be appropriate, but don't feel restricted to those. Feel free to say whatever you think. But let's start off with at least a scientific discussion or scientific comments about any of the afternoon's topics. So these just ask questions, can be as specialized or as general as you wish. And does anybody have anything to, yeah. And if you're close to a mic, please use it. If not, just stand up, and if you have a booming voice, you can just stand up and let your voice boom.
I guess this is mostly for Dr. Orchard, although the other ones can answer as well. Has much progress been made in methods for chemically removing CO2 from the atmosphere?
Well, the basic chemistry is very easy and well known, and they do it to get sulfur out of coal smokestack gas too. The question is just sort of the energetics and then what you do with the carbon after you get it. I would have thought a priori that it would be much easier to get carbon out of a smokestack gas because it's much more concentrated. But what I've been told is that if you want to treat a smokestack, you want to pretty much get 90% of the carbon or 99% or something like that in order to call it effective. Whereas if you're trying to capture it out of the atmosphere, you can sort of blow air through and take a tiny sliver of the CO2 out if that's the most efficient. You don't really worry about getting it quantitatively. So it's more expensive energetically to get it out of the atmosphere, but it's not as bad as I would have thought.
Okay, so the technology is sort of there, but it's just not cost effective.
Well, yeah, because nobody's willing to pay us to take carbon out of the air, so we'd be a total loser.
So can you do?
But it could be done.
Can you do it without using fossil fuels, which burn more CO2?
No, that's the rub. You need energy.
You need energy
to do it, and if you use fossil energy, then you're sinking faster than you're floating. Yeah. But that's my optimistic hope, is that after things go to hell in a handbasket and things just keep getting worse, they will start scrubbing CO2 out. It'll be like the biggest oil spill. And when that happens, the U.S. is going to get handed a big bill because 25% of that CO2 is ours.
Thank you.
We also need a place to store them.
That's another problem.
Another problem. And the quantities that would be involved here, that's really still an outstanding issue. I guess it's an engineering issue more than anything else.
The quantities of carbon?
Yeah.
Well, there are
CO2.
large saline aquifers
right.
that could have a large capacity to store carbon. But at some point, the whole endeavor of mining carbon, burning it, and putting it back in the earth just sounds like a stupid way to do things.
Yeah. Sorry.
Could you talk a bit about how you get your data and how you ensure quality control? I'm just interested in the process. Do you get government data? Do you collect the data? Because it seems like so much of what you guys said here today really depends on that data. So I'm just interested in how you collect, gather, and analyze that data.
So I think this is a question for all of the panel. Whoever wants to start out first. Michael, how do you get your data?
Well, we have a laboratory, and we do analyses in the laboratory. Turns out our analyses are focused around measuring gas concentrations in ice cores, which give us accurate time scales for the climate records. Then we get a lot of data from other laboratories that measure other properties in ice cores, and then there's a huge paleoclimate community that measures climate records in of many different forms over a whole range of time scales, and That data is almost all publicly available, either in the publications themselves or in databases. And then some projects that we work with involve remotely sensed data, and that's available through NASA. And other projects involve data collected by national laboratories. This would be greenhouse gas concentrations, for example, and that data is also publicly available.
Sean? Or?
To say it is really a mix, but a lot of the ice core projects or deep sea drilling projects really are international scale, where several countries will come together, and in the case of ice cores, there's, I don't know, Michael, a dozen in the world, maybe 20 of these longer, deeper ice cores. That it's not like hundreds and hundreds of stations that have data, so it's a really larger scale projects and carefully archived and almost always publicly available after maybe a couple of years of having the PIs have the first look at that data. And then within the larger satellite and instrumental record, which is really now just our last few decades or into the 1800s for some of the surface station data, this is run by national monitoring agencies in general under guidelines from World Meteorological Organization, so there are a certain set of standards you adhere to, and that data is made public, but it's on a national level that it's collected, so it's sometimes handled differently by different countries, but at the international level, the standards are set and that data is coordinated.
So Andy, it seems magical that we can measure the winds on Neptune.
Just take pictures and watch the clouds move.
So my work is mostly theoretical modeling. So the processes that go into what transforms the CO2 concentration in the ocean or whatever are constrained by things that people have measured and by theoretical things like thermodynamics or Newton's equations of motion or whatever. And then I get something out which I then can compare with data. But I don't sort of put data into the model exactly. I try to grow the model to then sort of resemble the data in some way. Is how data works in my world.
Does that answer your question? Okay.
I bet you're thinking, I bet you're wondering, how can we trust the data? And how can we trust the process? And I think the trust is that every scientist is looking over the shoulder of every other scientist. And it's very hard to get away. It's possible to get away with distorting the facts, but it's hard. And we work very hard to make sure this is a trustworthy process.
Especially since science is sort of a free market of ideas, kind of a dog-eat-dog. We can stab each other in the back, get famous doing it. That's what we do. That's what we're supposed to do. If I had reason to believe that global warming was not an issue, and I could prove it, I'd be famous. I wouldn't run with her.
So recently there was a report that scientific fraud is double what it was 20 years ago.
Scientific what?
Scientific fraud was about double what it was 20 years ago in terms of the number of papers that were retracted or the number of errors that were found in papers. Do we believe that that's a problem in our field?
More of a private problem in the financial world personally. I don't think there's much scientific fraud. As Andy says, it doesn't last.
For those of you using models, can you speak a little bit about the advances in modeling and how that might be able to improve our predictability?
Well, computers are getting faster and faster and cheaper, but the calculation for the actual climate of Earth that we would like to do would have much higher spatial resolution, and that would require a much smaller time step, and we'd like to do it for much longer model simulation time. So basically, climate scientists are going to leave the table hungry for the foreseeable future computationally.
I think one issue with climate models and climate in general is that you have really fast timescales, fast things going on like tornadoes and weather and so on. And then you have climate changing on year-to-year timescales, and you have things which change on timescales of hundreds of thousands of years, like ice sheets. Getting them all in a single model is still impossible, and likely will be for the foreseeable future. So although computer models are a big help, the biggest lack is still our own CPU power, I think. Alison.
Sean, on this one, you said in your talk, and that was interesting, about the Arctic entering a new normal. And I wonder if you could just elaborate a little on what that might mean, and what we might be looking at, and what sort of we can expect to maybe see.
Yeah, and it connects back to your question about what is normal for this when we have pretty limited observational period. But we've seen, I mean, the WMO, the World Meteorological Organization, has traditionally defined a climate normal as a 30-year average weather conditions for a place, for a region. And that was originally, I think, based on, you know, we had 30 years of data, so let's call that a climate normal. And it's conveniently about a generation is what we get used to. And even in my time in the business, we've actually had changes in what's normal from that definition, sort of our generation, what we're used to experiencing for weather. So we went from the normals from 1961 to 1990 to 1971 to 2000 and now 1981 to 2010. And you see what's normal has changed because the average temperatures have risen through those 30-year periods. But in the Arctic, for things like the sea ice and Greenland melt, it's not just like a small change. It's really a radical shift in what's normal, and the concept of a sort of a decadal or a 30-year change. But that's really based on 35 years of data for some aspects of Arctic there. But if you compare 70s, 80s in the Arctic to the last decade, it's a very different place in almost every aspect. In summer, at least. Winter is still cold and dark. Snowy.
I have a question for Michael, actually, which is a question that I'm often asked, which is we talk about CO2 forcing climate, but then somebody says to me, well, we'll look at the paleo record. We see that the temperature changes first, and then carbon dioxide follows. So isn't it temperature that's causing the carbon dioxide to change? And I often struggle to give a succinct answer to why that's not the case, even though the record seems to think it is. So what's the answer to that question, Michael?
Well, let me talk about the origin of the question first. I think what it is that at the end of the last ice age, you can see from looking at the ice core records that Antarctica warms. And based on analyses of 5 to 10 years ago, Antarctica warms, and then 500 years later, the carbon dioxide concentration starts going up. And climate skeptics latched on to this result to say climate controls CO2 because climate changes first and then CO2 goes up. Anybody who knows anything about Ice Age climate knows that Earth actually started warming about 21,000 years ago. So we're not talking about a few hundred years difference between the time CO2 started going up, and between the time Earth started warming and CO2 started going up, which is actually questionable if there is a difference in those two records. We're talking about a 4,000-year difference between the time Earth started warming at the end of the last ice age and CO2 started rising, which of course is a much stronger argument for climate being independent of CO2. In fact, we know that Earth's temperature can vary independently without CO2 changing. Probably not by very much, but it can certainly change. And the role of CO2 is not necessarily to initiate climate change. During the last ice age, the role of CO2 was to enhance climate change. In other words, climate started changing, and as a result of climate changes, CO2 started going up. But the CO2 increase enhanced the warming and increased the amplitude of the glacial to interglacial temperature change. So, you know, my response to the argument is to say that climate started warming before CO2. In a sense, that has to happen, and mainstream climate scientists understood 30 years ago that that has to happen, because CO2 doesn't just make up its mind to go up. Something happens that causes CO2 in the atmosphere to rise because it's coming out of the ocean. So there's a change in the physical climate system that makes CO2 go up. But the increase in CO2 amplified the warming from glacial to interglacial times.
Any other sort of scientific types of questions or comments from, please.
I'd like to, again, thank all of you. I'm asking a question that kind of orbits in the constellation of responsibility, just the facts, ma'am, and an advocate, something like that. I come out of environmental humanities. My wife and I have a project in religion and ecology, trying to bring religious tradition seriously into these issues with some understanding of the facts that you've laid out. And so I really applaud what's being done here, because it seems to me this is part of the responsibility of the scientists. You're giving of your time to lay out some, for some of us, it's very difficult to grasp the dimensions of what you're saying, but you know, try and listen very closely to enter into the narrative that you're giving. And the style of your narratives is also very interesting to me too. Andrew, when you started your comment about humility, I mean, I find that arresting right away, that someone talking about climate brings us with that kind of a metaphor into what he's dealing with. And again, David, I heard so many of your comments, you know, when it goes to hell in a handbasket, we'll do X, Y, or Z. So the narratives that you thread through the facts also come across to me. And so I'm very interested in that kind of dynamic where we have the possibility of the information that you're conveying having effect on policy makers and also on the general public, and the fact that we have very little response from the public at large to really invest in policy making. So I guess my question is the sense of the narrative that you're using and how we might communicate better. It's a large question in the area. If you can take it anywhere, thanks.
I'd like to try a flippant response that's nonetheless serious. We should fund people to take pictures of the dying polar bears. In other words, we have to get the public interested, and they are more interested in the polar bears than they are in the temperature 100 years from now. And it's flippant, but we've got to get a human living element into it to make a sense of urgency. If our warm, furry mammal friends are dying, I think that would produce more effort than maybe something that we do here.
With apologies to you and to Sean, polar bears are really far away. They don't really matter to me in my daily life. Don't you think communication of something much closer to our lives would be better than polar bears?
Yes. Tell me what it is. I mean, polar bears, baby cubs are cute. No, but
droughts and the price of food.
Yeah, what about people right here starving?
People are not practical, they're emotional.
But you can show people. You can show people suffering from climate change, not just polar bears.
If we can connect, and there is a connection between droughts and wars and starvation and climate change, and we have to make sure that point is made too.
But I'm hearing some new metaphors too. I mean, when you were reaching down into the deep earth, those metaphors, I think, are beginning to have some traction with us. The sense of deep time, this hundreds of thousands, millions, billions of years. Although difficult to calculate in the general public, I think we're beginning to have a sense of a larger universe story, or our place. And certainly religions have some resistance, but without going down that line, just the metaphors of deep earth and deep time are having traction. And I think that's one way climate science has not been presented extensively, at least in that regard.
Do we think that we're not communicating enough? And secondly, if it is the case that the problem of climate change is really a long-term one, possibly hundreds of years, maybe
thousands.
Thousands of years, there's no way we can predict.
Thousands. Say the words hundreds of thousands.
Hundreds of thousands. Okay, hundreds. Well, okay, you're making that point. If the problem is on such a long time scale, there's no way we can predict the evolution of human society on that time scale. So perhaps we shouldn't be too concerned about it at all. Because after all, 400 years ago, nobody could have possibly predicted technological advances that we've seen in the last 100 years. So perhaps we shouldn't. Should we even worry about what the planet will be like in 1,000 years' time? I mean, I'm asking that question. I'm not giving an opinion. I mean, why worry? I mean, not only will I be dead, but our children will be dead and our grandchildren will be dead.
And I guess since I'm the one that's making a big fuss over the long time scale, I guess I should deal with this answer. What if, I mean, one of the main objections that people have to nuclear energy is the long-term storage of the waste. What if we could change, what if it wasn't going to last for 50,000 years, radioactive waste, but it's only going to last 100 years? That wouldn't make any difference to us practically either, because we'll be dead in either case after, before that comes up. But to me, that would make a difference, in my opinion, about nuclear energy. There's something about changing things forever that does something for me. Now, economists, they do this discount rate thing, so anything more than 10 years out, they don't care about it. But I'm not with them. But you're right, it's a philosophical issue.
Yeah.
I went to a 2-day seminar here at the end of last semester, and it was mostly scientists, social scientists, as well as climate scientists. And at the end of 2 days, the question was asked, one side was looking at it from the macro level, one more from the micro level, and at the very end of it, the response really was, well, it's very interesting to look at it from your perspective. Well, it's very interesting to look at it from your perspective. And then they were asked, well, how can you work together? And it seems that we need more of that, because the social scientist is going to look at trends. Okay, you've mentioned this before, you've got to hit people where they live and breathe. So with a mother, it's going to be the health of her children. With a business person, it's going to be the economics. And there have been some connections drawn, for instance, the cities that are going to be impacted by rising tides and what kind of economic impact it's going to have to Miami, to New York, to Philadelphia. Those are the kind of things that get business people's attention. And if you can draw, and as more and more of these climate disasters happen, it forces people to work together in community more. That's when people start to help their neighbors. Then they've been impacted by something called climate change. So it seems to me that there needs to be more dialogue between the social scientists who's looking at, the trends in social mores and psychological views of climate change, and the climate people who are looking at trends from a computer model that aren't really relative to people's thoughts, words, opinions, and as you mentioned, some of the emotional responses that really get people to start to pay attention. So there's like this black hole, there's a disconnect there that is not being bridged.
Certainly seems to me it's going to be very hard to get policymakers and business people interested in anything with a time scale horizon of more than a couple of decades. But should we be trying to convince them of the long-term problem, or should we be trying to say that there are problems here and now?
Well, I think the short-term problems are serious enough that we can engage people. And I'm wondering, I've a bit of experience working in the British government on policy in the Foreign Service, and we very much try to use multipliers by going out, engaging business, civil society, and using them then to influence. I'm just wondering whether the climate scientist community, obviously very disparate, a lot of different institutions, whether there is a mechanism by which it is possible to identify and work towards engaging with key constituencies like the religious, like business, and so on, to try and therefore use them as a multiplier to have that impact that will change policy. And it worked pretty well in the UK. The CBI, the main business organisations in the UK, are now on board and fully accept climate change. And that was, as a result, in some ways, of a very direct effort, targeted effort to persuade them. And I'm not sure whether that effort exists here or whether it's even possible given that the climate scientist community is so large and so disparate.
Well, Britain, as you point out, has a very long history in this, not only in the climate area, but many other areas of public consultation on sort of controversial ethical and or scientific issues. And so I admire that. I mean, I think it's terrific, but their effort is not only focused, as you know, on the climate area, but it's more broadly spread on a whole series of areas in Great Britain. It's very admirable.
I'm actually pretty pessimistic. I mean, I look at the futility, apparent futility of conserving oil. No one's slowing down the use of oil. We may switch to coal, but and drive electric cars driven by coal, but I don't see any progress there. And climate is even worse because it's farther off in the future.
I read that 80% of the people in the U.S. have experienced some climate disruption that could be attributable with some degree of clarity to climate change. I think that social things like what people believe or who they elect or whatever can change kind of without much prior warning. The fall of the Berlin Wall and things like that. Nobody anticipated that stuff. So if the science is right and the climate disruption is just going to ramp up, I don't actually view it as the climate scientists' problem to solve the public perceptions. I think the public will figure it out on their own eventually, and it's not like, it's a special climate scientist's special interest. It's in everybody's interest. So I'm not as pessimistic as you, because I just can't. You look at the end of the century scenarios, burning all the coal and everything, and I just can't believe that it could happen.
But how can we not be pessimistic, given your talk that carbon dioxide will stay in the atmosphere for hundreds of thousands of years, and B, the fact that if there's oil and coal in the ground, we will extract it and burn it.
Winston Churchill once said of us that we can be counted on to do the right thing after we've exhausted the alternatives.
Yes. And so if there is hope, where is it going to come from? Is it going to come from scrubbing carbon dioxide out of the atmosphere, or is it going to come from not using the fossil fuels that are in the ground?
I think if we were just out of coal, it wouldn't be a technological issue. You would just come up with new ways of generating energy. There's not enough oil to cook the planet anyway, so it's just a question of making a decision.
There's a lot of coal in the ground. If we burn all the coal, carbon dioxide in the atmosphere will go up by, I don't know, you probably know
a lot.
A lot.
Well, I think that slavery wasn't ended mostly globally for economic reasons. It was ended probably in spite of economic reasons. It was ended for ethical reasons. I think releasing CO2 to the atmosphere is clearly causing harm to others, especially people in the deep future. And so I think that same sense of ethical evolution of humankind, which I think you can see if you look over the centuries, not necessarily one year to the next, but I do think humankind is advancing. We can make the decision. It's not that hard.
I think that's actually an extremely important point you're just making. The issue is not going to be solved by a little more science. Science has taught us what we need to know here, and we'll need to know more, and I think it's done great work in this area. But it's only damage to others that matters, and therefore that's an ethical question in my view. It's either geographical others who are in different geographies, or generational others, people who are in different generations. And that's not a scientific problem, that's an ethical problem. But what we owe to some others, people other than ourselves, other than those who are living now, or other than those that live in the US right now. And so being able to transform this problem on the basis of all the great work that scientists have done into an ethical concern might be something that motivates people. I'm just speculating now, I have no idea if this would be right or not. But you know, this is not the only area in which the public hasn't paid close attention to what scientists have said. And that's another kind of problem. But I think in the climate area, as I watch what's going on, I just think that if we need to refigure this problem, it's an important scientific problem. More scientific work has to be done in all kinds of areas. I completely support that. But someone has to reconfigure this to the public to say, look, it's not only a scientific puzzle which we have to continue solving, but it's an ethical problem regarding what we owe to others. And that seems to me is, if we don't get to that stage, then I do despair as to what it is that would motivate people. Because it's not for our lifetimes, as you've just pointed out a minute ago, that this really makes a big difference. It's for some other people in other spaces or other generations where it makes a big difference.